So today we're going to be talking about simulations. Now, last time we talked about the three different types of probabilities: the intuition, relative frequency, and equally likely outcomes. For simulations, we're mainly going to be looking at the relative frequencies. Now, some events, it's going to be a pain in the butt to do these trials. So, a lot of times we actually use a simulation. What a simulation is the process of running trials using random numbers to find the probability of an event happening. However, you must have equally likely outcomes for the events, and you must have a key. Those are two of the biggest things that we need for this. Every single event must have an equally likely outcome. And we have to have a key. Because without the key, you would understand what the numbers mean. However, a reader would not. Now, sometimes we are going to give you just a list of random numbers from a random number generator. However, sometimes we won't. Your graphing calculator will be able to spit out some of these random numbers for you. So, your calculator steps is first, you're going to go to math, and then you're going to move over to where it says prob. One of your options says rand int, and then it's going to ask you three questions. It's going to ask you for your lower, your upper, and your n. For this class, we're always going to set our lower to 0 and our upper to 9. Basically meaning that the random numbers that we're going to be generating are going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then n is the number of numbers we want. Sometimes, in fact, most of the times, we're going to set n to be 1. Because if we need more numbers, we can just hit enter more times. So then you'd hit paste, and then you'd hit enter. And the nice thing is, if we want another set of random numbers, we don't have to go through this process again. We can just hit enter again. And we can hit enter as many times as we need then. Another special note, you need to run minimally 3 trials, at least 3 trials. Because remember, we talked about the law of large numbers last time. The more trials we run, the closer the probability will be to our theoretical or the actual probability. So run as many probabilities or run as many trials as you can. However, minimally run at least 3. So let's look at example 1. Example 1 says, a cereal company is giving away a prize in each box of cereal, and they advertise, collect all 6 prizes. Each box has 1 prize, and each prize is equally likely to appear in any given box. Amanda wonders how many boxes it takes on average to get all 6 prizes. So we're going to use the random numbers below to run a simulation. For this one, let's just do 3. However, we need to know what numbers represent what. So we need our key. So for the key, since there are 6 prizes, let's say the numbers 1 through 6 are prizes. Number 1 is the first prize, 2 is the second prize, 3 is the first prize, and so on, all the way to 6. Meaning the other numbers, so numbers 0, 7 through 9, we're just going to ignore. And the reason why we're going to ignore them is because in the word problem, it says each box of cereal has 1 prize. There is not a box without a prize. The other key thing that we need to check is to see if they're equally likely to appear. And we do see, it does say each prize is equally likely to appear. So we can do this simulation. So we're going to go through the numbers. And it doesn't matter where we start in this list, but I'm going to start at the very top left just to make life a little bit easy. And what I'm going to do is I'm going to just list the numbers out. Because our goal is to get all 6. So I'm just going to make a little list off to the side of 1, 2, 3, 4, 5, and 6. And once I get to one of those numbers, I'll just cross it off. So starting off, my first number is a 1. Awesome. That's a prize. Then I have a 5. That's a prize. Then I have a 6. That's a prize. The next number is a 6, which we can't cross off because we already got that prize, so we need to still keep going. We got a 2. That was a prize. A 4. That was a prize. A 7, which we are going to ignore. A 6, which was a prize that we already had. A 0, which we're going to ignore. And a 3, which is the last prize that we needed. So to count through them, it took us, 1, 2, 3, 4, 5, 6. Ignore the 7. Ignore the 0. And we have 3. So 1, 2, 3, 4, 5, 6, 7, 8. So it took us 8 boxes to get all of those prizes. Let's do a second trial. And let's pick up from where we left off. So we have an 8. We have a 7, 8, 2, 1, 8, 2. I keep on going. I know in this long strand, you'll have it. So this is just a section of the numbers up above. So I'll make my list again. 1, 2, 3, 4, 5, 6. And I'll cross the numbers off as I get the prize. So we ignore the 8, 7, 8. We have a 2. We have a 1. We ignore the 8. Already have that 2. Ignore the 9. We have a 5. Ignore the 9. We have a 4. We have a 3. Already have the 1. A repeat 3. A repeat 3. A repeat 2. A repeat 2. Ignore the 0. We have a repeat 3. 2 repeat 1s. A repeat 3. Ignore the 0. A repeat 5. And a 6. So this long strand, there are some numbers that we ignored. Well, let's count out how many boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 boxes. Go ahead, run the third trial yourself and see how many total boxes we get. So, from running it, here's my chunk. From this chunk, I'm ignoring the 9s, 7, 8, 7. I'm ignoring those numbers based off of my key. Going through, I have, there's my 4, 5, 2, 7, 1, 3. So this ended up being 9 boxes. And we could run more trials. Remember, the more trials we run, the more the relative frequency probability gets to be the actual probability. But since in the problem it says, on average, we are going to find the average of these 3 numbers. So we're going to do 8 plus 17 plus 9, and we divide that by 3, we get roughly 11.3. So to answer her question, we can say, based on 3 trials, you will collect all 6 prizes on an average of 11.3 boxes. For any of these simulation problems, always end it in a sentence. And the format for these sentences are pretty much going to be the same, based on however many trials. You will blah, blah, blah. Let's look at the next example. Example 2, we don't have numbers. So go ahead and pull up your graphing calculator. In this problem, it says your teacher has invented a game called 3 rolls to 10. You roll a fair 6-sided die 3 times. If the sum of the rolls is 10 or greater, you win. If it is less than 10, you lose. What is the probability of 3 rolls to 10? You're going to use a random number on the calculator to help. Since it is a fair 6-sided die, that tells us that all outcomes are equally likely, and we then need to make our key. So on a key, or for the die, the numbers are 1 through 6, so we can kind of use the same key as before. I'll say numbers 1 through 6 are dice rolls, because that's what you would get. And then the rest we are going to ignore because it's impossible to get a 0, 7, 8, or 9 on a die. Now, some of these trials, your calculator is going to give a different number than my calculator, which is fine. For some of these trials we're going to go through, your trials, like I said, might have a different outcome. And for this one, let's run 6 trials just to show that the more we do it, the more your outcomes will, once again, get closer to be the actual probability. So for the first trial, after I ran my numbers, these were the numbers I ended up getting. Our numbers that are successes, basically the 1 through 6, in this case are 3, 2, and 2. So 3 plus 2 plus 2. It's a 7. And that means we take the L. We lose. For my trial 2, after hitting enter multiple times, these were the numbers I ended up getting. My dice roll numbers were 3, a 1, and a 5. I like that 5 because it gets us closer, but a 3 plus 1 plus 5 gets us a 9, which is another lose. My third trial, these were my numbers. I ended up getting numbers that worked were 2, 2, and a 1. Ended up getting is 5, which is another lose. So go ahead and take a moment and run 3 trials on your own. Trials 4, 5, and 6. See if they're a win or a loss. So like I said before, your trial numbers, the numbers in your trials might be different than mine. They might be the same. So, trial 4 for me, it took a bit until I could actually get the successful numbers. I got a 4, a 3, and a 6, which gave me a total of 13, which was my first win. My trial 5, I ended up getting a 2, a 3, and a 5, which ended up getting me 10, which is also a win. And then for my last trial, numbers I ended up getting were a 1, 6, and a 2, which I'm getting a 9, which was a loss. So to find the probability of winning in this game, our frequency of wins is 2. Because I had 2 games of wins. If you had more, put it down. Or if you had less, put that down. So in my case, I had 2 wins out of my 6 trials. So to answer the question of what is the probability of winning 3 rolls to 10, I would say, based on 6 trials, the probability of winning is 6 over 2, or 2 over 6. Let's look at example 3. Example 3 has 2 parts to it. And this one is a slightly different key that we need to look at. It says a beach resort makes most of its money during spring break. To make money, it needs to not rain at least 4 days out of the 10 days of spring break. Based on the weather forecast, there is a 1 out of 5 chance it will rain each day for the 10 days of break. Design a simulation that would model the weather for the 10 days of break. Now, here's the deal with this problem. It says that there's a 1 out of 5 chance that it will rain. So to determine the numbers that we are going to have to use for our key, a fifth of them has to be rain days. So if we think about it, we have numbers 0 through 9. That means it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is a total of 10 numbers. So a fifth of that gets us 2. So that means 2 numbers have to represent rain. Now, it does not matter which numbers we choose. I'm going to make my life easy. I'm going to say numbers 1 and 2 are 0 and 2 are rain days. Meaning numbers 2 through 9 are not rain days. So once again, to start off this problem, we had to take that chance, that 1/5 chance, times the total number of numbers that we have. Now, when we go in the calculator, we're still going to use 0 for our low. We're still going to use 9 for our upper. But since we're using all of these numbers and we're not looking for particular numbers or skipping numbers, our n, we can actually say, is 10. Because there are 10 days of break. So by doing so, the first 10 numbers that my calculator spat out are this. So I need the number of rain days to be 4 or less. So the rain days I have 1 and 3 zeros. So chance for rain on this would be 4 out of 10. So would they make money? Yes, they would. My trial 2, these were the 10 numbers that my calculator spat out. Going through it, I say I have 1, 2, 3, 4 ones and a 0. Meaning my chance of rain would be 5 out of 10. And since we need that number 4 or smaller, no, they would not make money that week on that spring break, that simulation. Go ahead and run the last trial yourself and see what numbers you get. Mine, I ended up getting these numbers. And this was actually a pretty good week for them. They only had one snow day, or not snow day, rain day. So because of that, yes, they would make money. If you want to run more trials, go ahead. Remember, the more trials we do, the more accurate our answer will be. So for our final answer for this problem, or this part, based on 3 trials, the probability that they will make money during spring break is 2 out of 3. As 2 of those 3 trials were yeses. Now, if you notice, we have a second part to this. And because we have a second part to this, we need to then use our same key. The key that we decided on, we have to use for all of the problems. So keeping that in mind, we know zero and 1 are still rain days. All of the numbers are not rain days. So based on the given results of a similar situation designed by your friend, is it plausible that the resort will make money over spring break? Explain why or why not. Now, if we look here, instead of just listing out random numbers, your friend organized it into a dot plot. So go ahead and take a moment, look at the dot plot, and see overall, would they make money on this? So, for this, we know 40% of the numbers can be rain days. We know that. 4 out of 10 of the days have to be rain days. That as a percentage is 40%. Or 0.4 if you want to talk about the decimal. There are 25 out of 50 rain days in this simulation. That means that 50% of the days are rain days. Due to this, they will not make money during spring break. Once again, we have to use the same key that we used